Hey guys, welcome to this video on exponential equations and functions. So, what is an exponential equation? Well, an exponential equation is an equation in which the unknown occurs as part of the index or exponent. So, for example, if I go 2 to the power of x, so our unknown is x in this case. We could plot these out on a graph if we wanted to, and that's where exponential functions come in. And we have touched on exponential functions in the past when we were doing graphing, but we're going to now go into it a little bit in more detail. Let's have a look for a moment. If we've got a to the power of x being equal to a to the power of k, where a is obviously the same, then x is going to be equal to k. Now, that's because our bases are both the same, and all of this is going to be leading into logarithms, which we're going to talk about very soon. So don't get scared about the name. It's not as hard as it seems. So what we're going to do for the first part of exponential equations is we're going to look at solving. Let's say if I had 2 to the power of x is going to be equal to 16. What is x? Well, for this we really just have to rewrite this 16 here as having a base of 2. So 2 to the power of what equals 16? Well, in this case, it's to the power of 4, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the power of x is just the same as 2 to the power of 4, in which case x is just equal to 4. Now, it's interesting to note that we've got it like this, and at the moment it's really trial and error and a bit of guesswork to work out what it's going to be equal to. What if I had something that looks like this? Well, I've got 3x plus 2 is going to be equal to 1 over 27. Ooh, now this is an interesting one. Well, 27, you guys should recognize as being 3 to the power of something. In this case, 3 to the power of 3. So we could rewrite this fraction here, x plus 2, as being equal to 1 over 3 to the power of 3. Now, remember for our index laws, that we could again rewrite this as 3 to the power of minus 3. Now we're getting somewhere, because they're both in the same base. We can then go x plus 2 is equal to minus 3, in which case x is going to be equal to minus 5. And that's sort of the process that we step through to do it, and it's just recognizing that 27 can be written as 3 to the power of 3. Again, it's just a bit of guesswork. It's realistically learning 3 times tables and 2 times tables and using all your tables and then powers as well to work out what's going on. Alright, the last example I want to go through for exponential equations, then we're going to talk about functions, is what if I have 4 to the power of x being equal to 8? Now, the bases here are the same. They're different. But we can rewrite them as having the same base. If we think about it, 4 we could rewrite as 2 to the power of 2. So this could become 2 to the power of 2 to the power of x. And 8 can be rewritten as 2 to the power of 3. Now, how did I know that these were both going to boil down to bases? Again, it's just recognizing that they'll boil down to base 2. So ideally we want to try and get it down to the lowest base that it can. In this case, it's going to be 2 to the power of 2x is equal to 2 to the power of 3. So we're going to have 2x being equal to 3, which that means that x is going to be equal to 3 on 2. And that's how we solve these ones. It is just recognizing that 4 and 8 can be reduced down to 2 to the power of something. And most numbers will be able to be reduced down to something like that. Alright, let's talk about exponential functions. So, exponential function is going to have the basic form of y being equal to a to the power of x, where a is going to be greater than 0, and a is not going to be equal to 1. Now, the reason it's not going to be equal to 1 because 1 to the power of any number is just 1. Even to the power of 0, it's just 1. So, how could we look at what these graphs look like? Well, if we take y is equal to 2 to the power of x, and we make up a table of values for this, for values of x and values of y, we could then just plot the points out. We could also chuck it in our graphics calculator, or we could chuck it into Desmos or any kind of graphing package and see what it's equal to. And that's really what exponential functions are. We could have y being equal to 2 to the power of x plus 3, and it'll shift it around a bit. We could chuck a negative sign in there and it will change it around. We could go 2 to the power of negative x and we'll change it around. And what we'll do, we'll investigate all of these during class. So that's really it for exponential equations and exponential functions. So hopefully you've got something out of it. If you've got any feedback, please let me know. And if you've got any questions, just ask in class. So thank you for watching, and we'll see you next time.